in this data to find the relevant one. And so, most of you don't know Algolia, but I'm sure you used it already. If you went on some well-known websites like Twitch, for example, and you started searching for video games to watch, in the background, Algolia is being used to find the right video games for you. And that's pretty easy to see a search engine, because you are typing a query and getting some results. But search is more than just a search box. It's about giving your users what they're looking for. But what they're looking for can be expressed in many different ways. An example is Periscope. You probably know this app where you can watch streams of people filming something. Of course, you can search through the app via text, but the main interface is a map on which you zoom and you find videos that might be interesting for you in this area. Well, this is a search interface. The intent is expressed when you zoom, and Periscope sends Algolia the coordinates of the place you're zooming at, and in a few milliseconds, we return the relevant streams for you to watch. So, ultimately, any user can express their intent in a very unobtrusive way. Imagine today you're trying to build a voice interface to find monuments in Berlin. Maybe you will let the user ask, is there a monument at a specific address? And that's a way to ask for something. But maybe the user will just say, hey, what's around me? And you will use their geolocation as an address. If you put Berliner monuments in Algolia, you can then just put the geolocation of the user as a query, and you will find the Bundestag and the other known monuments that might be in a specific range of them. Ultimately, maybe just the name or the age of the user is the input. I heard yesterday some people are going to build a dating app. If you ask the user what's their name, what's their gender, what kind of sexual orientation they are looking for, then you have a user profile. This is an input. Just put all the users into an Algolia index, and you'll be able to show them other people that they might be looking for. And that's a query. It's just a simple way to express it. So, these are a few examples. But ultimately, we're here to talk about voice search. And this is because we're here to talk about voice search. And voice search is getting big. We can see it a lot at Algolia, as today we have quite a few customers, like 5,000 different customers maybe in 100 countries. That's why I say that you likely used Algolia already. And more, these customers are coming to voice ecosystems. As we saw in the presentations yesterday about actions on Google and about Alexa, you can see that a lot of big players that used to communicate with websites and that moved to mobile apps are now pushing their content to voice platforms. But ultimately, the more content you have, the more you need a good way to find what your user is looking for. And this is what brings us to voice search. Because voice search is taking off way faster than we expected. Last year, Google shared the statistics that 20% of all the searches done on the Google engine are via voice. And this is just the beginning. By the way, if you check their report, it's 50% of searches if you take millennials in the US. So you can see the trend is really growing. And Comscore predicts that it's not only Google. Ultimately, 50% of searches will be done by voice by the end of the next 2 years. So there is really a trend that we want to follow here. If we, as developers and product builders, want to give our users what they want in the form that they expect. And voice brings a lot of possibilities, because ultimately it lets your user interact naturally with what features your service can propose to them. But it comes with quite a few challenges that you need to address. Like when we moved from websites to mobile apps, and suddenly your big website with a lot of data had to get crammed into 3 inches of space. Today, when you're providing a feature through a voice interface, you have a lot of challenges to face. And the first one is being fast, actually. Because you want the conversation to be intuitive and to move forward in a natural way. Today, the bottlenecks in voice interfaces is often the intent detection system, but it can easily be your database. And you don't want to add a few milliseconds of delay at every interaction, because that would be the difference between an intuitive Alexa skill and a very clumsy one. Then, relevance is very important in voice search. Because when you are on Twitch and you search for video games, you'll be able to see 10 results and even to load more if you don't find the right ones at first. But when you get answers via voice and you're on your bicycle asking, what's a nearby bakery? You cannot wait for 20 results. The 3 first ones need to be super relevant. And so this is key to your user's experience. It's more than finding the right results, actually. It's also about interpreting the query in the right way. When your users are typing in a search box, they're used to being concise and to saying, for example, find red laptop. That's very simple. But when they're talking to your assistant, they will be more, I need a laptop and I'd love it to be red. And you need to be able to interpret these queries correctly. You need also to be quite tolerant. Search engines are getting better and better at handling typos, which is essential, especially on mobile interfaces, because people do typos. I'm the first one. On voice, it's a whole new problem. Speech-to-text is not as good as we would like to, and today maybe 5–10% of what people say are not understood correctly. If you don't have a data store or a search engine that can easily adapt to speech-to-text mistakes, to utterance issues, to ums, ers, etc., you wouldn't provide a good experience. Finally, there are some specific UI needs for conversational interfaces. First, for voice interfaces themselves, you need to know how you want to build the interaction, and you need to be concise, and there are a lot of small things that you can do to make your voice interactions better. But if you're going for multimodal interfaces, like Karen mentioned yesterday, you want the screen to be a helper, a companion for your voice project. And so you need to craft this screen with care so that it's helpful for your users and it doesn't get in the middle of what they're trying to do. So let's start with speed. Today, you just want everything to happen fast. When you're starting to search on Amazon, you immediately see results coming, and so you can refine on the way. When talking via voice, you'll have the assistant answer, but you still want this to be snappy. And so you need very small round trip to access your data, or to filter it to find monuments that are in the next kilometer around me. That's why speed of the processing and of the search answering is important, and that's something we just cover by default. First of all, because we have very optimized search processing, so you'll be able to quickly get the results, but also because you can replicate your data near to your users. For the hackathon, likely everybody will be in Berlin, but if your project gets successful, and I wish you to have a successful project, maybe tomorrow you'll have users in the US, and in South Korea, and in South Africa. And you want all of them to have a good experience, provided they can talk English, if your skill is in English. For that, I'll show you later, but you're able very easily to replicate the data across the globe and don't have to manage it yourself. So speed is covered. This brings us to the next and the biggest challenge of voice search, which is relevance, providing good results. And relevance starts with being able to handle typos or misstructured queries. If your project is multimodal, maybe you're going to have an action on Google and people can type as much as they speak. They will do typos. Even if they speak, there will be text-to-speech errors. There will be misunderstandings. And you want to handle that. Being able to handle this is essential if you want your user to feel they're understood. And this is even more important in voice interfaces. Because as we've just seen on this great presentation on the personality type of your interface, if your interface feels natural and puts the user at ease, they will of course want to interact a lot more. But if they feel frustrated, if they feel they're not getting understood, they will just close your app and try to find another skill that fulfills their need. So this is something you need to take a lot of attention to. And there are some tools that can help you understand the user better. One of them is using synonyms. Because, especially with voice, users will be saying stuff in many different ways. If I'm asking APIs for voice user interfaces, maybe I'll say APIs for VUIs. Maybe I'll say APIs for conversational interface. There are a lot of ways I could phrase this. And if you enable synonyms, you'll be able simply to match what the user actually means. Likewise, stop words is important. If your query contains, find me the best search engine for VUI, what you actually care about is best search engine for VUI. So configuring a few stop words will let you provide a lot more relevant results. But it can go further. One thing you can use is query rules that will help you understand what the user means and define consequences for it. Let's say you're doing a product search via voice. And so the user can say, hey, I'm looking for a red computer from Dell. You could define a set of rules that would automatically match colors, automatically match computer types or brands. And actually, that could take this as an opportunity to showcase a promotion, the Dell Christmas laptop offer. So, taking an example that we heard again, maybe the product builders of the dating voice app want to have a bit of a head start in the dating. And so maybe one thing they could do is that facing specific keywords, the builder could just promote their own profile, for example. Ultimately, wait, one sec, my bad about that. No way this doesn't. Okay, sorry. Here we go. Okay. So you could define rules that will react to what the user says and provide some appropriate consequences. But what do you do if you don't have something that corresponds exactly to the user's query? Should you stop there? Probably not. Handling the cases where you don't have the exact results is what will set your experience apart from the other ones. And this is something you can do by deciding what is optional. A good example here is a too precise query, which once again happens very frequently with voice interfaces. And I learned it the hard way. If you're making a clothing advice app that can take someone's wardrobe and give them advice on what to wear for a given opportunity, maybe the user will say, I'm looking for a red dress with flowers for tonight's cocktail party. And that's a pretty sensible request. But what if you don't have anything for cocktail parties? You can probably show a partial result that will be good enough. And so by defining optional words, you're able to look back until you find something. And maybe you won't have red dress for cocktail parties, but probably you have red dress with flowers, or the opposite. But you'll be able to give something to your users and to not leave them confused, which is also very important for their experience. But experience is not only about users, especially in such a short context, where here you have only 36 hours to build something. Having tools that help you instead of getting in the way will help you build something as cool as possible. And you might be wondering, this is interesting, but I'm not a developer. Well, today with APIs, everyone can be a developer. It used to be a time where for building a voice interface, you needed to know systems programming. You needed to know audio processing. You needed to know natural language understanding and a whole lot of concepts just to build a simple turn the light on system. But today, with systems like Actions on Google and Alexa that give you a very easy way to start conversational interfaces, with APIs like Algolia for search, like Stripe for paying, like Cloudinary for image processing, it's becoming easier and easier to build something on top of these components. And if we're coming to Algolia, you don't need to be a developer to build something cool. For example, if you have some data and you just push it in a few clicks, you'll be able to search very easily through your data. And so without any line of code, you'll be able to see how many data you have for one or another category and how it reacts to a given or another utterance. And if you have data to push, you could do it in the code, sure. But you can just click and type them manually even, or just upload a CSV or a JSON file. By the way, if you're looking for data IDs that you could use for your project, you'll see at the end of this presentation a link that will bring you a lot of datasets that you could very quickly start using to build something on top of Algolia. And it's not only about putting your data and searching within it. Today, anything can be done in a very easy GUI interface. Of course, everything I show here, you can do it through the API. So if you'd rather see a console than a screen, you can definitely hack and access the analytics or manage your infrastructure through the console. But if you want, and if some of your teams want to make something more relevant, want to check the analytics for your skill, want to replicate your data in the US, these are things you can do in just a few clicks, which lets any person in your team contribute. Then, for people that want to actually code something, because you will need to integrate Algolia with your app, it's a few lines of code, but still, you have to code it. We have quite a few tools that you will find handy. First of all, we provide API clients in your favorite language. And I'm pretty sure of this because today we cover 15 of the most well-known languages, from Python, JavaScript, and Java obviously, to a bit more rarer ones like Go or like Rust. Maybe not Rust. Check out on the API client side. We are having more and more integrations every day. But that's not only it. For those who are building a GUI as well, maybe you're building a graphical interface for the Amazon display. Maybe you just want a website on the side of your app. We have front-end libraries that will let you build very quickly something. To give you an idea, we have an Algolia app in which we index talks to help people find search talks at conferences. I gave my coworker Tim the link to the Chatbot Summit this morning, and in 20 minutes, he built an interface for you to search through all the Chatbot Summit's videos of last year and this year. And these kind of interfaces are actually pretty quick to build, because with front-end libraries, you just say how you want it to look. You want a search box, you want the results, maybe pagination, maybe search filters. All of these are readily available for building websites or mobile apps. It's just up to you to use them. Finally, we have quite a few in-house engineers that are experts on search, obviously, and that are getting more and more expertise on conversational and voice integrations. I'm myself getting focused more and more on these topics, and I'm looking forward to helping you turn your project into the next killer app for this hackathon and hopefully for the upcoming weeks. To give you some examples, here are a selection of voice skills or voice interfaces that leverage Algolia to provide a good experience. There are some Alexa skills that you can check out. Name, meaning, and origin will tell you where your name comes from and what it means. Houston Baseball, which is also available as an action on Google, will let you get your daily dose of sports news so that you can quickly follow the Houston baseball teams. There is a more generic skill that my coworker Dustin built as an action on Google, which is baseball scores, and which can help you follow your favorite team across the matches that they will have. So this can actually be handy on a day-to-day basis. And finally, if you want to see a multimodal interface that is both conversational, so voice first, but that also displays results and lets you, as a user, interact with the results in an intuitive way, you can check out The Musicologist, a project I built which gives you music advice through a conversational interface. I don't have access to the source code of the first ones, but the Musicologist source code is freely available on GitHub. I advise you to check it out if you want to see how you can quickly integrate a conversational platform, in this case Dialogflow that Peter presented this morning, and a search engine, here Algolia. So these are a few ideas, and I hope that you're gonna try to make something cool using both search and voice. And if you do so, we have a few prizes for you. Tomorrow, when we'll announce the winners of the competition, we will have 5 professional microphones that we will be giving to the winning team, so that you can build even better voice and sound experiences. And hopefully you'll make a good use of it. So, I talked enough. I propose that I show you a quick demo of how you can concretely use Algolia to adapt your relevance and to provide the users with what they're actually looking for. Just get a seat. Here we go. So, can you see well here? In the back, do you see it correctly?
Maybe
more? Yeah, I can do more than one. Is it better now? I think I'm pretty much at the maximum. Is it okay right now? I could also, yeah, no, that would be okay. Let's get it this way. So this is just a data set that I just uploaded, which is basically a list of products. So you can check. There are like phones, there are TVs, there are printers. It's just a data set of e-commerce products, pretty standard. So let's start from the beginning with an index that is Let's start from the beginning, where you just uploaded your data. So when you create an index, you can either push your data with the code or simply upload it as a file. And as soon as you did it, your search engine is already ready to use. It might not be perfect, but you can already use it, for example, to search for an iPhone. And you'll find some. That's great. But what if your users have spoken and they have searched for an iPhone? Sadly, suddenly, you don't get that much good results, and you're getting some weird car stereo accessories that say they're compatible with iPhone. We can probably do it better. And the first thing would be to remove those stop words that are not important for the query. If I'm asking for an iPhone or a red robe, ultimately the A or the N is not that important. So let's just remove the stop words. You could provide your own, but we give you languages with pre-made list of stop words, so that you can in one click remove all the small words that have not much meaning in English. And so once you did that, oh yeah, I should have loaded those. So when you do that, the settings get updated and your index is rebuilt in real time. We make sure when you change your data that we let your users access the previous state until the new one is ready and we replace it directly. So if you use Algolia to store your data for the hackathon, you can update your index on the go and your skill will be accessing always to the latest version of the data or of the settings. So now the settings are updated. Whoops, I need to zoom again. Now the settings are updated. If I'm searching for an iPhone, an is ignored, and I'll be finding what I'm looking for. This is good. Let's move forward. Whoop. Where is my pointer? Okay, whatever. So let's move forward. Now you can search for an iPhone. That's awesome. But maybe your users will give you more details. Maybe they will be looking for an iPhone with 32 gigabytes. Yeah, that will work. The issue is that there's no result. I thought I had 32 gigabytes iPhones. Oh, I have some. It's just that the data I got is not well formatted and it's 32 GB. And that's cool, but I don't want my users to have to say GB. So let's add a synonym. Using analytics, you will quickly see that your users are saying stuff in the way you don't expect them to say it. And that's normal. But when you create synonyms, you'll be sure to bring them back in the place they are trying to be. So if I see that my users are saying gigabytes instead of doing 32 GB, I can simply add a synonym. And suddenly, they will be able to find it if they search for up. An iPhone with 32 gigabytes. Whoop. Oh, it's still updating. I don't see anything. Is it applied? Demo effect, let's say. So what's the... Oh, maybe not the network is working. So we're getting an iPhone. The words are ignored. If I do 32 GB, that works. And if I do 32 gigabytes, that works as well. Okay, the synonym was not updated soon. That's an issue you can have when developing, is that it takes a few seconds for your index to rebuild. So you have to keep it in mind and not start screaming at your laptop like I'm used to be. It's not efficient. So once you have synonyms enabled, you're able to help your users find what they search, even if they say it differently. But maybe it's more than just rephrasing what they say. Maybe you want to adapt to what they are searching for. So for example here, my users could be looking for products with free shipping. So they could look for an Apple TV, and we have some. But if they say with free shipping, that doesn't really work. And that's too bad, because free shipping is actually in my dataset. It's just that I need to tell my engine how to use it. And for that, you can define rules that explain the behavior you want. Yeah.
With the 2GB, why doesn't it understand? Or it's only because you're looking in the description bar.
So when I do an iPhone with 32 GB,
yes.
So when I did push the data, I told it to look in the name, manufacturer, category, and description of the data. So by default, it searches there. But here, defining stop words helps my engine understand that un and with are not important. So you should prioritize the actual iPhone rather than something that has with in it, but that isn't the right product. And that's the point of setting your search engine, is that you are the one who knows what's relevant or not for a user. So you are the one who can configure it the right way. So moving to another example, if your users are looking for an Apple TV, they'll find it. But if they do it with free shipping, suddenly no results. And that's because we didn't tell the engine how to react to shipping criteria. If we want, for example, a filter to be automatically applied, we could do a rule for shipping options. And we'll say that if the query of the user contains a shipping option, free shipping, fast shipping, etc., then we should probably do something special. One thing we could do is to automatically filter to show only results that have free shipping or fast shipping or worldwide shipping. Of course, if the users say, I want an iPhone with free shipping, you don't want to search with free shipping anymore. So we'll just remove the specific shipping criteria. And that's the power of using rules like this, is that whether the user said free shipping, said worldwide delivery, said whatever the values you have, you make a rule once and for all, and your voice interface will know what the users are looking for. So when you save the rule, and now you start looking for an Apple TV with, if I add free shipping, we see that the rule gets applied, and then suddenly we'll only show results that actually have free shipping. Of course, this is just an example. There is a lot more you could do by applying query rules, but at the end of the presentation, you'll find a small guide that will help you use any of those features. Last example of what you could do, I mentioned optional words. Because when you don't have something specifically for the user, you still want to send a reply. You don't want your voice interface to be confused. So let's look for something too precise, like a flat 4K smart TV with no glare. And believe me, there are a lot of too precise queries when you're building for voice. In this case, why would I show no result? Maybe I can find a flat 4K smart TV or flat smart TV with no glare. By just picking words until I find something, I should be able to give some result after all. So this is something I cannot show you directly by clicking in the dashboard, because you will need to set the optional words for the current query. But it's something you can do quickly in your code, or here, by adding parameters directly in the dashboard. And this will be useful for you prototyping, because you will be able to quickly test parameters without having to actually build something, deploy it, test it, and refine. You can quickly say, okay, for this query, I want the optional words to be the words of the query. This way, if I don't have flat 4K smart TV with no glare, I look for flat 4K smart TVs, or for smart TVs with no glare, or for flat TVs with no glare, until we find some results. Of course, this means you will have a lot of things that match, from very relevant on top, like a flat panel TV that is 4K and smart, that's already good, to very irrelevant results at the bottom. But you don't care about that, because your voice interface will never return 1,000 products. It will likely return the top 3 ones. And these optional settings will help you make the 3 ones as relevant as possible. Oops, well, fair enough. So, with this in mind, we're reaching the end of this presentation. I'd like to thank you for your attention, and I'll be happy to answer your questions if you have any.